The particle analyzer gives you all the control you need to do in-depth analysis of particle distributions. First, I'll tap the three dots at the top here, and we'll go through the settings and information page. The first option is for the cumulative distribution curve. This is on by default. A cumulative distribution curve helps you see percentiles and compare overall trends, rather than just where values are concentrated. If you don't need this, turn it off. But I'm going to leave it on. Next, we have the sieve stack section. You can choose between showing the sieve sizes in microns or based on standardized ASTM sieve numbers. If you're unfamiliar, a sieve stack is traditionally how you would physically determine the distribution of coffee grounds. You stack various sized sieves from smallest to largest and shake them until the particles stop falling through. Then you can see how much coffee fell into each sieve, and you have your distribution. By default, we provide 4 different sieve stacks that correspond with the stacks built natively into dFluid Omni. However, the stacks on CoffeeOS are all fully customizable. To edit one, tap the arrow next to it on the right side. From this page, you can add or delete sieves as you like. I'm going to add 1800, 1250, 560, 355, 224, 106, and 63. And I'm going to delete 100. Why? Because I can. I'll call this Stacko Pancakes. At the same time, I'll create another sieve stack just to check the fines distribution. So I'll add all the sieves under 300 microns, and we'll call this Fines Stack. Now I'll switch from the current stack to the Stacko Pancakes stack, and head back to the main tool page. From here, you can either swipe to the left to use the dFluid Particle Analysis coaster to take photos of your particle samples, or connect to dFluid Omni. That's what I'm going to do now. In the settings, I can open the Device Center and make sure Omni is connected and updated to the latest firmware. Now I'll prepare my sample. I can either push the button on Omni or push the test button in CoffeeOS. Once the test is complete, the results will show in the graph, and your testing instance will show up at the bottom. Test number 1. At the very top, you can see what type of distribution you have. On the control panel in the middle, you can see your D10, D50, D90, mode, SD, and mean. Each of these can be tapped on to display them prominently on the graph. Tapping, for example, both the D10 and the D50 will display that whole range. Swipe to the left on the control panel for the second set of controls. The top is about particle count, and the bottom is for viewing the contents of individual sieves. For example, if I want to know how many particles fell into the 500 micron sieve, I can tap here and see how many particles I've selected, what percent of the total is selected, how many particles there are total, and how many particles are in this specific test. By taking multiple tests, we can add them together as one large sample. So before we dive in, let's do a few more tests and get a better understanding of this sample. Okay, now you can see 4 total tests here at the bottom. I can tap each one to view the data from that test, or I can deselect to view all the tests as one sample. Or over here, I can select the 500 micron sieve again, and see what percent fell into that sieve for each test, or the total across all tests. Selecting a specific test will change the particle count from average across all tests to total count for the current test. After testing, I can still go back to the settings menu and change to the other sieve stacks. Think of it like re-sieving particles from scratch. The data from the whole sample is saved, so it can be re-sieved over and over again in any way you want without losing data. Let's switch to the fine stack and take a look at our data. You can see most of the particles are larger than 300 microns, but now you can see more granular data about the fines distribution. When a specific test is selected, you'll see a yellow triangle in the top right corner. This will allow you to take notes on that specific test. I'll tap New Note, give it a title, and write, "The fines on this sample have an interesting distribution." Notes you take will stay attached to the specific test that you place it on. Up at the top is your sample name, and below it is the folder that the sample is saved in. As soon as you complete a test, the data is saved. No need to press Save. By tapping the History button in the top left corner, you'll find all of your previous testing history. I can tap a previous test to view the distribution. From here I can choose to open the sample or press Done and go back to viewing sample history. By default, it opens the All Samples folder, but by pressing Samples here, you'll go back one folder layer where you can create folders for storing samples. Here I'll make a Kinu M68 folder. Up at the top, I can tap the plus button to create a new sample in this folder. Now at the top you can see I have a new sample in the Kinu M68 tests folder. If I want to change the folder that the current sample is in, I can tap the arrow at the top, tap Change Folder, and then either create a new folder or select an existing folder. From the same menu, I can either rename the sample or add notes attached to the entire sample, not just a specific test. The export tool is not available yet. Lastly, if you don't have a D-Fluid Omni for particle analysis, you can get a particle analysis coaster from the D-Fluid website and use your phone's camera. Just place the pad on a flat surface, spread the particles evenly so they're not touching each other, and line up the coaster in the circle window. Boom! Now I'm sure you're wondering what's the difference in accuracy between the dedicated equipment and the smartphone camera. It depends on your use case. The dedicated equipment will always be more accurate. Omni features an isolated testing environment with consistent lighting, consistent distance from the sensors, and an auto-dispersion algorithm that attempts to determine when the particles are dispersed as much as they can get. When using your smartphone, there are a lot of factors that will affect your results. External lighting can create shadows, there can be small distortions depending on the distance from the camera, the angle, etc. The benefit of using the particle analysis coaster comes from the distribution. Even if there are errors in your testing procedure, the distribution will still be correct relative to the size of the other particles that you've tested. As you make multiple tests, make sure that you stay in the same testing environment and try to standardize your process as much as possible. If you're going to be doing a lot of particle analysis and day-to-day consistency is important to you, getting a D-Fluid Omni would be the best option. However, to help you dial in your brews casually at home, snagging one of these could be perfect for you. And that's the particle analyzer.